In exceptions. In Python, all exceptions must be instances of a class that derives from base exception. In a try statement with an except clause that mentions a particular class, that clause also handles any exception classes derived from that class, but no exception classes from which it is derived. Two exception classes that are not related via subclassing are never equivalent, even if they have the same name. The built-in exceptions listed below can be generated by the interpreter or built-in functions, except where mentioned. They have an associated value indicating the detailed cause of the error. This may be a string or a tuple of several items of information. Example, an error code and a string explaining the code. The associated value is usually passed as arguments to the exception class constructor. User code can raise built-in exceptions. This can be used to test an exception handler or to report an error condition, just like the situation in which the interpreter raises the same exception. But beware that there is nothing to prevent user code from raising an inappropriate error. The built-in exception classes can be subclassed to define new exceptions. Programmers are encouraged to derive new exceptions from the exception class or one of its subclasses and not from base exception. More information on defining exceptions is available in Python tutorial under user defined exceptions. Exception context. Three attributes on exception objects provide information about the context in which the exception was raised. Base exception dot underscore underscore context underscore underscore base exception dot underscore cause underscore base exception dot underscore suppress underscore context underscore. When raising a new exception, while another exception is already being handled, the new exceptions underscore context underscore attribute is automatically set to the handled exception. An exception may be handled when an except or finally clause or with or a with statement is used. This implicit exception context can be supplemented with an explicit cause by using from with raise. Raise new exception from original exception. The expression following from must be an exception or none. It will be set as underscore cause underscore on the raised exception. Setting underscore cause underscore also implicitly sets the underscore suppress underscore context underscore attribute to true, so that using raise new exception from none effectively replaces the old exception with the new one for display purposes. Sorry. Example, converting key error to attribute error while leaving the old exception available in underscore context underscore for introspection when debugging. The default traceback display code shows these chained exceptions in addition to the traceback for the exception itself. An explicitly chained exception is underscore cause underscore is always shown when present. An implicitly chained exception in underscore context underscore is shown only if underscore cause underscore is none and underscore suppress underscore context is false. In either case, the exception itself is always shown after any chained exceptions, so that the final line of traceback always shows the last exception that was raised. Inheriting from built-in exceptions. User code can create subclasses that inherit from an exception type. It's recommended to only subclass one exception type at a time to avoid any possible conflicts between how the bases handle the R's attribute, as well as due to possible memory layout incompatibilities. C Python implementation detail. Most built-in exceptions are implemented in C for efficiency. C objects slash exceptions.c. Some have custom memory layouts which makes it impossible to create a subclass that inherits from multiple exception types. The memory layout of a type is an implementation detail and might change between Python versions, leading to new conflicts in the future. Therefore, it's recommended to avoid subclassing multiple exception types altogether. Base classes. The following exceptions are used mostly as base classes for other exceptions. Exception base exception. The base class for all built-in exceptions. It is not meant to be directly inherited by user defined classes. For that, use exception. If str method is called on an instance of this class, the representation of arguments to instance are returned, or the empty string when there were no arguments. Args. The tuple of arguments given to the exception constructor. Some built-in exceptions like OS error accept a certain number of arguments and assign a special meaning to the elements of this tuple, while others are usually called only with a single string giving an error message. With underscore traceback tb. Sorry. This method sets tb as the new traceback for the exception and returns the exception object. It was more commonly used before the exception chaining features of PEP 3134 became available. The following example shows how we can convert an exception of some exception into an instance of other exception while preserving the feed traceback. Once raised, the current frame is pushed onto the traceback of the other exception, as we have happened to uh, would have happened to traceback of the original some exception had we allowed it to propagate to the caller. Try then accept some exception. TB traceback is equal to system dot exception dot traceback raise other exception dot 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 with traceback. Let's see the example. Let's raise type error. Raise type custom type import sys. Okay, try raise accept case tb is equal to system dot exception traceback raise. Not a directory. This is just for illustration purposes. Try accept exception e e print e dot traceback print new line print e dot e dot cause print e dot class print e dot args print equal context. Let's run it. Now class is this one and ours is ellipsis comma this custom type error. Let's run it. Ellipsis arcs, this one is arcs. Let's run it. This is traceback object, this one traceback dot line number 10 print e dot traceback dot class traceback print e dot traceback dot hash. This is hash unique print e dot traceback dot tb next traceback next. This one is next print e dot traceback. These two are different. This is current and this is next. Print e dot traceback dot tb frame. This is frame at this file is this cell line number 17. Here we can see line number 17 here code module. So these are various attributes of traceback class. dir tb frame tb next tb last integer tb line number print e dot traceback dot tb last instance 146 print ln and then print cause was none, then print backslash n class traceback not a directory, yeah, because this one was raised. Print backslash n print args ellipsis comma and print context custom type error. This one is context. Thank you. Now underscore traceback underscore a writable field that holds the traceback object associated with this exception. See also the raise statement. Add not add the string not to the exceptions not which appear in the standard traceback after the exception string. A type error is raised if not is not a string. Add not print underscore e dot traceback dot add underscore not Let's run it. Okay. The aspect object has no attribute at not. Okay. Print e dot underscore underscore e dot underscore underscore. Um, Notes aspect dot underscore e dot a list of nodes of this exception which were added to add node. This attribute created when add node is called. Mhm. On it. App. Okay. Nodes. Exception. All built-in non-system existing exceptions are derived from this class. All user-defined exceptions should also be derived from this class. Exception arithmetic error, the base class for those built-in exceptions that are raised for various arithmetic errors. For example, overflow error, zero division error, floating point error. Exception buffer error, raised when a buffer related operations cannot be performed. Exception lookup error, the base class for the exceptions that are raised when a key or index used on a mapping or a sequence is invalid. Index error, key error. This can be raised directly by codex.lookup. Concrete exceptions. The following exceptions are the exceptions that are usually raised. Exception assertion error, raised when an assert statement fails. Exception attribute error, raised when an attribute reference, see attribute references or assignment fails. When an object does not support attribute references or attribute assignment at all. Type error is raised. The name and obj object attributes can be set using keyword only arguments to the constructor. When, when said, they represent the name of the attribute that was attempted to be accessed and the object that was accessed for said attribute respectively. Changed in version 3.10, added the name and object attributes. Exception end of file error, raised when the input function hits an end of file condition EOF without reading any data. Not NB. The io.io base.read and io.io base.read line methods return an empty string when they hit EOF. Exception floating point error, not currently used. Exception generator exit, raised when a generator or coroutine is closed. See generator.close and coroutine.close. It directly inherits from base exception instead of exception since it is technically not an error. Exception import error, raised when the import statement has troubles trying to load a module. Also raised when the from list in from import has a name that cannot be found. The optional name and path keyword only arguments set the corresponding attributes. Name, the name of the module that was attempted to be imported. Path, the path to any file which triggered the exception. Changed in version 3.3, added the name and path attributes. Exception module not found error, a subclass of import error which is raised by import when a module could not be located. It is also raised when none is found in sys.modules. New in version 3.6. Exception index error, raised when a sequence subscript is out of range. Slice indices are silently truncated to fail in the allowed range. If an index is not an integer, type is raised. Type error is raised. For example, let's do example. For example, try 1 divided by 0 c. Okay, and then accept exception as e, and then print type e. For example, let me zero division error. You can set it zero division error, zero division. If we say index error, so L is equal to 1 comma 2 comma 3, and let's try to print L of 7. So this one accept exception as e, print type is equal to e. Comment out this one and let's run it. Index error, because subscript 7 is not in the range of valid subscript. Valid subs is only 0 1 2, and if I say 2, this will not throw error and will print the value of 1 2 3. Okay. Except key error raised when a mapping dictionary key is not found in the set of existing keys. Exception keyboard interrupt raised when the user hits the interrupt key, normally Control C or delete. During execution, a check for interrupts is made regularly. The exception inherits from base exception so as to not be accidentally caught by code that catches exception, and thus prevent the interpreter from exiting. Note: catching a keyboard interrupt requires special consideration because it can be raised at unpredictable points. It may, in some circumstances, leave the running program in an inconsistent state. It is generally best to allow keyboard interrupt to end the program as quickly as possible or avoid raising it entirely. See note on signal handlers and exceptions. Exception memory error raised when an operation runs out of memory but the situation may still be rescued by deleting some objects. The associated value is a string indicating what kind of internal operation ran out of memory. Note that because of the underlying memory management architectures C's malloc function, the interpreter may not always be able to completely recover from this situation. It nevertheless raises an exception so that a stack traceback can be printed in case a runaway program was the cause. Exception name error raised when a local or global name is not found. This applies only to unqualified names. The associated value is an error message that includes the name that could not be found. The name attribute can be set using a keyword only argument to the constructor. When set, it represents the name of the variable that was attempted to be accessed. Changed in version 3.10. Added the name attribute. Exception not implemented error. This exception is derived from runtime error. In user defined base classes, abstract methods should raise this exception when they require derived classes to override the method, or while the class is being developed to indicate that the real implementation still needs to be added. Note: it should not be used to indicate that an operator or method is not meant to be supported at all. In that case, either leave the operator division method undefined, or if a subclass, set it to none. Note: not implemented error and not implemented are not interchangeable, even though they have similar names and purposes. See not implemented for details on when to use it. Thank you.